you may know, Professor Mirrlees is a Nobel laureate in economics, having won this prestigious prize in 1996 for his contribution to the economic theory of incentives under asymmetric information. Just now, during lunch, I have a little chat with Mr. Ronnie Chan, and he told me something. In fact, Professor Mirrlees did not do economics for his first 2 degrees. In fact, he did mathematics. And according to Mr. Chan, Mrs. Mirrlees told him that every night he would read some math before he go to bed. So without further delay, we're very delighted and honored to have Professor Mirrlees to deliver some special remarks today. Please welcome Professor Mirrlees.
It's been a great experience, and obviously the first thing one's got to say is that's great work that you've done, Ronnie Chan. This is the most splendid thing, and as far as I know, there really isn't anything like this in the rest of the world. But of course, also, I want to say to the people who've been doing all this research, it's true mathematics research. What great things you've done. I was cross-questioning the jury on the bus this morning as we came in to find out what people had really done. So I've got more of a flavour of it than most of you out there. And I thought it's really enjoyable stuff. Wish I'd had the same experience when I was young. But of course, for many years, I've been doing something rather different. There were several things that impressed me. I know that the Gold and Silver Awards went to people who'd done the work on their own, but many of the awards went to groups of people, 2, 3, even 4, and I think that's very fascinating. You would think it'd be really rather hard to cooperate in doing mathematical research, although it's become increasingly important. It happens that in economics, in mathematical economics even, cooperative research is the norm. That's the way we seem to do it. And in a way, prizes, of course, are about competition. But the sort of thing you'd think people would face up against one another and act independently. So I actually find it very attractive that nevertheless people will work together, can make discoveries together. Of course, what you've experienced, and I'm speaking to the prize winners, the award winners, you've gone through the real mathematical experience. John Coates used the term real mathematics, and I'm not sure whether what I do quite counts anymore, but it's something I believe in very much, and the real mathematical experience is getting a sense of a question that might be answered, and then working through the logic until you actually show that something is true. You actually solve a problem. You find the solution to an equation. You discover a theorem. The remarkable feature of the human mind, so that it can make that first step, it can think of a good problem. It can make a good guess that something might be true. It can even be convinced that something's true before the whole process of ordinary mathematical calculation is done. And this is the experience that you've got, that most of us did not get when we were at school, just solving problems that somebody else gave to us, that we knew had a right answer. It's something else to be getting out and chasing the unknown. That's what you've been doing. It's great. Now, thinking about all this, I hope that Ronnie Chan won't mind if I do a little commercial for another prize, because I'm actually quite interested in encouraging people who do mathematics to think of doing other things. Not stopping doing mathematics, but applying mathematics to various problems. I think an example of that might indeed be keeping water cold. But I obviously also have in mind such a thing as using mathematics in economics. Now, mathematics has become a little imperialist in the last 200 years as it's moved into doing all kinds of engineering. Obviously, computation is a very mathematical thing, but it has had a lot to do with the development of the importance of the computer in the world. But it has also moved into economics in a big way, so that it's very hard for anyone to do economics. I mean, in the sense of doing economic research, unless they're moderately competent, at least in mathematics. They've also tried to get into other subjects, have not always been so successful. I want to tell you an anecdote. A few years ago, precisely 5, I was lucky enough to be in Stockholm at the session for the Nobel Prize giving that was celebrating the 100th year of the Nobel Prizes. Been going on a while. I hope the Hang Lung Prize will do 100 years as well. Anyway, there we were, and I come from at that time, at any rate, I came from Cambridge University, and my college is Trinity College in Cambridge. And Trinity College there were quite a number of people there from Trinity College who were Nobel Prize winners. 3 of us happened to be standing together at some point. And one of us pointed out that we had all done mathematics as undergraduates in Cambridge. We'd done what is called the mathematical tripos. Now, when Alfred Nobel wrote his will, he was quite specific that there was not to be a Nobel Prize in mathematics. The rumor has it that he was jilted by a lady who married a mathematician. I hope nobody checks up in case it's not true. I think it's a great story. But there we were, standing around in Stockholm, all of us with Nobel Prizes, and we were all mathematicians. And we counted that four members of Trinity College, Cambridge, who had done mathematics, had got Nobel Prizes in 4 different subjects. Now that shows you how wide-ranging mathematics might be. And of course I'm setting you a problem there. If you know what subjects it's given in it, what subjects might have got it. So you know economics, because I'm one of them. Physics, that's not surprising. Physics is applied mathematics. And chemistry, which is actually computational chemistry. But the 4th one was literature. So, those of you who've been winning awards for doing good mathematics, maybe there's a novel out there in your future. But I just ought to fill this in a little. You've heard of the one who got it for literature, Bertrand Russell, the philosopher, who indeed wrote some pretty high-powered mathematical philosophy in his young days, but got it for that. So I suppose we still have our eyes on the physiology prize, and that's an area that's beginning to, well, it is quite mathematical. All these DNA codes and things now matter. And whether we can make any contribution to peace, there's an interesting question. But you will remember probably that G.H. Hardy, in his famous Mathematician's Apology, claimed that the great merit of his life was at least pure mathematics could do no harm, and he had therefore done no harm. And this is the closest thing to peace. So my really warm congratulations to everybody involved in this terrific enterprise. What a great thing you've done. Thank you.